friends, you're welcome back to my channel. My name is Faith Osemegbe, your online tutor. Today we're going to be learning about number-based system. Okay, a number-based system can be referred to as what? Decimal number system or base 10 number system. Okay, so we're going to have lots of examples today to explain more about number-based system, how you can convert your base 2 numbers to base 10 and your base 10 numbers into base 2. But right now we're going to be learning how to expand the following numbers according to the powers of their bases. Okay, now let's get right into it. Solution. A, we have 110,001 in base 2. So we want to write this, we want to expand this number according to the base number of 2 here. So before we do that, we need to know how many digits we have here before we can expand this number. We have 1, 2, 3, 4, 5, 6. Okay, but in number base, you start counting from the extreme right with the number 0, from 0 to the number you have there. So we're going to tag this as what? 0, 1, 2, 3, 4, and 5. Now, having labeled this from 0 to 5, we can now expand this number. So we're going to have 1 times the number base 2 raised to the power of what? 5 plus 1 times the base is what? 2 raised to the power of 4 plus 0 times 2 raised to the power of 3 plus 0 again times 2 raised to the power of 2 plus the third 0 times 2 raised to the power of 1 plus 1 times 2 raised to the power of 0. Now I want you to bear in mind that when you have a number raised to the power of 0, it simply means 1. Okay? Now 2 to the power of 0 means 1. And this is how we're meant to expand our numbers using the powers of their bases. Now, the next question. We have 4, 3, 2. We have just 3 numbers here, right? So this becomes 0, 1, and 2. And what's the power here? 5. So we're going to say 4 times 5 to the power of what? 2 plus 3 times 5 to the power of 1 plus 2 times 5 to the power of 0. And there you have it for the second question. Now the last question, we have 3, 2, 5, 6 to the power of 10. Sorry, to the base of 10. We want to expand this number to the power of their bases. And if we are to label this number, we have 0, 1, 2, 3. Right? Now we're going to have 3 times the base 10 to the power of 3 plus 2 times the base is what again? 10 to the power of 2 plus 5 times base 10 to the power of 1 plus 6 times base of 10 to the power of 0. And there you have it. Please feel free to drop your comments in the comment section if you have any, and we'll be right back. Okay, so we're going to have other examples to help us understand more about number bases. So from here we can just group everything together into brackets, right, for clarity's sake. Okay, here. So it makes it easy for you to calculate it further. Now we have some questions on the board that says convert these to base 10. Sorry, to base 2. And we have all of them in their basis of 10. Okay, so let's convert all of these to base 2. Now, what are we going to do with these numbers? Well, first of all, going to convert each of these numbers using the division rule of dividing them by what? 2. And by doing so, we are converting these base 10 numbers to base 2. Let's continue. Alright, question 1. We want to convert 324 in base 10 to base 2. So I'm going to start dividing by 2, right? 2 into 3 will go once, remainder 1. Into 12 is 6. Into 2 is 2. Remainder 0. Now this remainder is very important because you're converting it to base 2. Okay, from base 10 to base 2 is very important. Then we go again. 2 into 16 is 8. 2 into 2 is 1. Remainder 0. Now let's continue. 2 into 8 is 4. 40, right? Then into 1. That's 40. 2 times 40 is 80. Remainder 1. Then we go again. 2 into 40 is 20. Remainder 0. 2 into 20 is 10. Remainder 0. 2 into 10 is 5. Remainder 0. And then 2 into 5 is 2. Remainder 1. And then 2 into 2 is 1. Remainder 0. And then 2 into 1 is 0. Remainder 1. And your answer is, you start counting from what? The bottom to the top. So we have what? 1, 0, 1, 0, 0, 0, 1, 0, 0. And that's the answer for this question. Okay? Now let's move on to question 2. Okay, we can just do our question 2 here simultaneously because of space. Now let's convert first of all 54, right? So into 54 we have 2, that's 27, remainder 0, right? Then 2 into 27 we have 1, then we have 3, remainder 1. 2 into 13 will give us 6, remainder 1, right? Because 6 times 2 is 12 plus 1, 13, isn't it? Then 2 into 6 will give us 3, remainder 0. And then 2 into 3 give us 1, remainder 1. And then 2 into 1 is 0, remainder 1. Remember, we're calculating it from the bottom to the top. So, therefore, this first one is in base 2. Therefore, we have 1, 1, 0, 1, 1, 0. But we're not done yet with this question because we have a fraction here of 3/8. Now, for us to get the binary number of 3/8, we have to convert it to decimal. Okay? Now, let's convert 3/8 to decimal. 8 into 3 is impossible. Put a 0, add a decimal, and add a dot. 8 in 30, that will be 3. 8 times 3 is 24. When we subtract, we have 6. 8 into 6 is impossible. Add a 0. 8 in 60 will give us what? 5, 6. 8 times 6 is 48. 8 times 7, so that will be 7, 56. Then we subtract, to have 4. In 40 is 5. 8 times 5, 40. So the decimal for 3/8 equals what? 0.375. So now, in order for us to convert our decimal here to binary number, we have to multiply it by 2. In other words, we're also converting it to base 2. So if you're converting the decimal to any base, you multiply it by the number of the base. Okay, so what to multiply by 2? So from here we have 0.375 times 2 equals what? 2 times, this equals 0 plus 2 times 5 is 10 plus 0.5, right? Sorry, 0.75. Now, from here we'll say 0.75 times 2 equals 2 times 5 is 10, right? 7 times 2 is 14 plus 1, 15. Remainder 1. So it becomes 1 plus 0.50. Then we'll say 0.50 times 2 equals 0. 5 times 2 is 10. Remainder 1. Right? So that's 1 plus 0. Right? 1 plus 0, because 5 times 2 is 10, then the remainder is here. Now note that the remainder here is what is on the left hand side. What is remaining? 0.375 times 2. 2 times 5 is 10. Okay, I didn't put the 0 here. 0. Carry 1 up here. 2 times 7 is 14 plus 1, 15. 3 times 2 is 6 plus 1, 7. Remainder 0. That's why you have the 0 here. Then second one is 0.75 times 2. 2 times 5 is 10. 0 carry 1. 2 times 7 is 14 plus 1, 15. So write down the 5. Then the remainder is 1, which is what is written here. 1 plus 0.5. Then the next one we have 0.5 times 2. 2 times 5 is 10. 0. Sorry, 0 times 2 is 0. Then 2 times 5 is 10. 0 remainder 1. This is the one. So the answer here is what? Having gotten to this point, how do you rank your answer here? It's from the top to the bottom, not from the bottom to the top. When you're dividing, you rank it from the bottom to the top, but when you're multiplying, you rank it from the top to the bottom. So we're going to rank it from here down, okay? And this becomes 0, 1, 1, because it's in decimal, right? So the answer will become what? 110.011 in base 2. Okay? And this is the final answer for this question. Now let's move to question 3. Now we'll first of all convert 20 to base 2. 20 into 20, 2 into 20 will give us 10. Remember what? 0. Right? 2 into 10 will give us 5. Remainder 0. And 2 into 5 will give us 2. Remainder 1. And 2 into 2 give us 1. Remainder 0. And 2 into 1 give us 0. Remainder 1. So we have what? 1, 0, 1, 0, 0 for now. Then we can now get the fraction of this, which is 3/4. Fraction of 3/4. Let's convert. 4 into 3 is impossible. Put a decimal and a 0 behind it. 4 into 30 is 7. 7 times 4 is 28. Then we subtract. We have 2. Right? Then 4 into 20 is 5. 5 times 4 is 20. Then we subtract. So we have 0.75. Now, like we did here, we're also going to do the same here. Then we multiply 0.75 times 2. That gives us what? 1 plus 0.5, because that's the remainder of 1. Then 0.5 times 2 gives us 1 plus 0, isn't it? And I think that's the final answer, because we have 0 here as the remaining number. So from here we now have 101.00.11 in base 2. And there you have it for question 2. Done this, we can now move to question what? 4. Question 4. We are to convert 3725 to base 2. Now let's start. 2 into 3 is 1, remainder 1. Right? In 17, 8, remainder 1. In 12 is 6. In 5 is 2, remainder 1. Let's go again. 2 into 862, we have 9, 3, 1, remainder 0. Into 932, we have 4, 6, 5, remainder 1. That's 4 times 2, 8, remainder 1, right? In 13 is 12, 6, 2 times 6 is 12, remainder 1. Yes, so in 465, we have 2. In 6 is 3. In 5 is 2, remainder 1. We have 1, 1, 6, remainder 0. We have 5, 3, remainder, sorry, 2 into 10 is 5. 5 times 2 into 11 is 5. 5 times 2 is 10. Okay, then it's 16. It's 8. Remainder 0. Then 2 into 5 is 2. Remainder 1. In 18 is 9. Remainder 0. In 29, you have 1, 4. Remainder 1. In 14, you have 7. Remainder 0. In 7, you have 3. Remainder 1. In 2, you have 1, remainder 0. And in 1, you have 1, remainder 1. So we have 1, 0, 1, 0, 1, 1, 0, 1, 1, 0, 1, 0, 1, 0, 0, 0, 1, 1, 0, 1 in base 2. Yes. And that's the final answer for question 4. I hope it's interesting. You're enjoying the calculation. Okay, so from now, we're going to move into how we can convert base 2 numbers to what? Base 10. Sit back and let's continue. Now, we're going to convert binary numbers on the board to base 10 numbers. All of these numbers are in base 2. Okay, so we want to convert all of these to base 10. Let's get right into it. Number 1, 1, 0, 1, 1. Now, remember in the first exam that I did on expanding with different bases of 2, 8, and 10, this is how we're going to do it. Watch and learn. So we have 1 times, the base is what? 2. To the power of how many? 1, 2, 3, 4. We have 4 digits here, but we'll consider this as what? In binary, we'll start from 0, 1, 2, 3. Okay? So this is 1 times 2 raised to the power of what? 3, plus 0 times 2 to the power of 2, plus 1 times 2 to the power of 1, plus 1 times 2 to the power of 0. So from here, we're going to expand. What is 2 to the power of 3? That's 2 times 2 times 2, and that is 8. So we have 8 plus 0 times 4 is equivalent to 0, plus 1 times 2 is 2, plus 1 times 1 equals 1. So we have 8 plus 2 is 10 plus 1, 11 to base 10. And that's the final answer. When you're given questions like this to convert binary numbers to base 10, just have it at the back of your mind that binary numbers are numbers in the base of 2. Alright? Question 2. 1101.110. Now you can see we have a decimal in this question. So just as we did here, we're also going to apply it here. So now let's label our numbers. We have 0, 1, 2, 3, and here we have 1, 2, 3. Now in decimal, you count forward, but in negative form. So this is minus 1, minus 2, and minus 3. Okay, still in the base of 2. Alright. Now, let's convert. We have, okay, let's start from here. 1 times 2 to the power of 3 plus 1 times 2 to the power of 2 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 0. Right? Dots is still what? Plus. You are still adding. Plus 1 times 2 to the power of minus 1 plus 1 times 2 to the power of minus 2 plus 0 times 2 to the power of minus 3. Okay? So now, from the first one, we have what? 8. 2 to the power of 3 is 8 plus 2 to the power of 2 times 1 is 4 plus 0 times 2 is 0. 1 times 1 is 1 plus, now this is same thing as saying 1 over 2 to the power of 1, right? Plus 1 over 2 to the power of 2 plus 0 over 2 to the power of 3. Now from here we have 8 plus 4 is 12, and 12 plus 1 is 13. We have 13 plus 1 over 2 plus 1 over 4, right? 0 divided by this is 0. So what do we do next? We're going to add this fraction together, and this gives us what? 2 plus 1, which equals 3 over 4. And therefore our answer is 13 wholes 3/4 in what? Base 10. Okay, I hope this is well understood. It's very easy to understand. Just follow the steps and you get it right. Question 3. We have 1, 1, 1, 0, 0, 1. So once convert this is in base 2, convert this to base 10. So we have 1 times 2. Okay, let's label it first. 0, 1, 2, 3, 4, 5. 1 times 2 to the power of 5 plus 1 times 2 to the power of 4 plus 1 times 2 to the power of 3 plus 0 times 2 to the power of 2 plus 0 times 2 to the power of 1 plus 1 times 2 to the power of 0. Then we can now add all together. So we have 1 to the power of 5 is what? 16 plus 2, that's 32. We have 32 plus 2 to the power of 4 is 16 plus 2 to the power of 3 times 1. Remember, always look at the number you're multiplying with. Okay, 1 times 16 is 16, 1 times 8 is 8, 0 times 4 is 0, 0 times 2 is 2, 1 times 1 is 1. Remember, any number to the power of 0 means 1, and 1 times 1 equals 1. So we have 32 plus 16 is 48, 48 plus 8 is 56, 56 plus 2 is 58, and 58 plus 1 is 59. to the base of 10. And that's the answer for that. Question 4. We have 110, 110. So what converts this to base 10? So now let's label. We have 0, 1, 2, 3, 4, 5. 1 times 2 to the power of 5 plus 1 times 4 to the power of 4 plus 0 times, 1 times 2, this is 2, because of the power, that's why I wrote 4. 0 times 2 to the power of 3 plus 1 times 2 to the power of 2 plus 1 times 2 to the power of 1 plus 0 times 2 to the power of 0. So we have 1 times 2 to the power of 5. If you look at here, we have 32 plus 1 times 2 to the power of 4 is 16 plus, this is plus, not minus, plus 0 times 8 equals 0, 1 times 4 equals 4, 1 times 2 equals 2, and 0 times 1 equals 0. So the answer is 32 plus 16 is 48, plus 4, 52, plus 2, 54. So we have 54 in base 10. And that's the final answer for this question. Now let's move on to question 5. Question 5 says 1100.1001. So what converts this to base 10? Okay, we have 0, 1, 2, 3, minus 1, minus 2, minus 3, and minus 4. Alright? 1 times 2 to the power of 3, right? This is 2. Plus 1 times 2 to the power of 2, plus 0 times 2 to the power of 1, plus 0 times 2 to the power of 0, plus 1 times 2 to the power of minus 1, plus 0 times 2 to the power of minus 2, plus 0 times 2 to the power of minus 3, and plus 1 times 2 to the power of minus 4. Okay? So we're going to add all together. 1 to the power of 2 to the power of 3 times 1 is 8, plus 2 to the power of 2 times 1 is 4, 2 to the power of 1 is 2 times 0 is 0, 2 to the power of 0 times 0 is 0, plus 1 over 2 plus 0 plus 0 plus 1 over 16, right? 1 over 16. So we have 8 plus 4 is 12, plus, what's the LCM of this? That will be 8. 16 in 2 will give us 8. So 8 plus 1, that's 9 over 16. Right? Can it be reduced further? No. So the answer is what? 12 wholes 9/16. And that's the final answer for this round. Okay, we've come to the end of today's lesson. I hope you enjoyed yourself while learning how to calculate numbers in the binary number system. Okay, do have a wonderful day, and so please do well to like the video, leave a comment at the comment section, share the video if need be, and lastly, subscribe to my channel. I'll see you in my next video. Bye.